present today. I am Ian Blanchflower, working from Accelonix. So if you have questions following this trial, this presentation, I'll be in the exhibition hall and can answer questions. Okay. Today I'm going to be talking about Accelonix and some of the process equipment. So we are a service provider and sales organization proposing certain building blocks which you can then integrate into your battery assembly. So next slide. Just to give you some explanations of who is Accelonix. So we've been working in the industry for over 30 years, bringing sales and technical service to equipment users, production sites in France, also in England and also in Benelux. So our process partners are leading engineering manufacturers of production equipment and test equipment, principally for the electrical and electronic engineering markets. And so for test, assembly, inspection software. These are proven systems. They're in mass production already, and these can bring you some advantages for battery assembly. So we'll talk about those as we go forward. This is just a slide, a background slide, to my understanding, the battery market there's a tremendous growth and also a tremendous diversity in applications. And so to really attack that market, you need to have fast, adaptive solutions and mature technical process choices. And that is what we want to bring you in this presentation. So we're going to explain how does Accelonix propose these solutions. So we have basically three proposals that we want to talk about. The first one I'll be spending most of this presentation talking about. So it's ultrasonic wire bonding for battery pack connections. But we're also working with Schugenflug for dispensing solutions. Our involvement with Schugenflug has been for power module assembly, but there's a lot of applications for battery assembly in applying heat management materials, adhesive materials, and sealing encapsulant materials. So we can talk about that. There's an Atlas on Atlas Copco, where is our partner. They have a stand also in the exhibition hall. So please go and talk to them as well. The third is for Accelon. So Accelon is proposing for a long time X-ray equipment, which we use for fault finding in electrical components. And this is for the tomography. We can make a 3D scan of your battery and for find internally any short circuits and fail joints. So the main part of this discussion is about Hesse and ultrasonic bonding. Ultrasonic bonding is actually a very, from what my discussions here are, it's a poorly known technology. But it has a lot of advantages in the way that the joint is made. So the joint is a frictional connection between the two metals. Ultrasonic energy is generated at 60 kilohertz. Other frequencies are possible, but it's typically 60 kilohertz. And this is then dissipated between two materials, and the two materials then will molecularly join together due to the energy ultrasonic. So it's a cold process. It's a very repeatable process, and the fine process origins of Hesse bring a very key advantage. So we've got some videos which I can show you. Hesse itself is a leading manufacturer. So it's been in the market since in the 90s, and its factory is based in Paderborn. It's a very modern factory, very well organized. This site is so well organized, it's producing machines for worldwide. In Europe, so it's one of the few suppliers that we have are doing that, and this is big quantities. They've recently extended the site and doubled the quantity, and they will have plans to do more than that in the next few years. So the different product ranges that Hesse produce, I'll just briefly go over this. So there's the wire bonder, which is on the next slide. Smart welding, which is a similar technology to wire bonding, but has different advantages. When you're talking about fine process, so you have the process, but you also have to think about how is you're going to integrate this into your production. And Hesse can do that. They can give you project management to automate your equipment, to interface to your line, to communicate the data. And then they also have a structure which allows you to make prototypes. So if you have to start production, you haven't got the equipment there, you can go to Hesse and they will make your prototypes to run your systems with. So ultrasonic wire bonding or ribbon bonding, here you have some images. So basically it's adding a wire or a ribbon, and this is typically in aluminum or copper. The process is low temperature, so there's no melting, there's no splash, there's no residue. So it's a very secure environment for particular for battery welding, which is can have some dangerous aspects due to the flammability. So it's a very reliable and very repeatable joint. This is an advantage because it gives a low resistance joint compared to other kinds of weld joints. So this is an interesting solution. It's of course qualified fully. It's already in mass production for many, many years for module assembly. And another interesting aspect is the weld can be reworked. So if you're repairing welds or changing battery cells, you can take the battery cell out and then replace it quite easily to weld a new joint. So typically you're doing it in wire, so you can have 300 microns to 500 microns. You can make one wire, you can make several wires. You can do it in ribbon as well, and likewise you can do one ribbon or several ribbons. There's guidelines in terms of how much current they can carry, so we can share that information. This one is a video, so showing you the process. So first part of it is the camera on the bump head is moving around. Then the second part, it's measuring the heights. And the last part is making the connection. So you'll see there are no tooling necessary to keep the two parts together. The programming of this is actually very quick. You can program and set up a program within hours, where you compare that to other solutions which need several weeks to focus. For example, laser welding. This is one of the key strengths. Is a very flexible solution. Okay. So the other technology is smart welding, and Hesse have an approach where they've taken a wire bonder, they've taken out the wire feed and the ribbon feed, and they've increased the power. And by increasing the power, you can make a very larger current connection, copper on copper, aluminum on aluminum, or different kinds of materials. It's again a cold weld, so no melt, no critical residue, very reliable joint, and the metrology is there to control. So we have ultrasonic powers up to 1.5 kilowatts, which can make a copper to copper joint 3 millimeters by 3 millimeters with 1.2 millimeter thick copper. This is an example. There are larger solutions on study. It's a smart welder. They call it smart because it inherits a lot of the features from the wire bonding. So this is the navigation by the camera to identify and realign the weld joints. This is the active movement of the Z and the control of the force and the interesting energy during the weld. And of course, the weld is so well controlled, you can program it in different process parameters and different scales. A typical weld will be between 30 to 500 milliseconds, depending on the size of the weld. So all that process is controlled actively. There's also the tool is very fine, so you can access narrow cavities to make miniaturizations if you want to. So this is again a video of a smart welder in action. So you see the kind of speed. Here there's no material brought to the system, but the weld is the bus bar is already positioned. But again, you see there's no clamping, and once the pattern reconnaissance is made, the bonding executes automatically. The next slide is to give you an example of multiple contacts on copper, because this is actually for a power module, and it's wire bonding onto a DBC circuit. The DBC circuit is very fragile, and that's one of the aspects that you need to be able to control when you're welding onto a surface which can bend. You need to be able to control the force. Okay, so when you're considering your pack design, these are some of the aspects that you need to consider. The first is the choice of the material. Certain materials are weldable by ultrasonics and certain others are not, so we need to be careful of that. We need to also dissipate the energy in the joint, so it's important that mechanically it's stable. How much time have I got? Then there's the design rules. So when you're making the weld for wire, you have to have the three elements. You've got the tool, the cutter, and the feed. On an ultrasonic smart weld, you just got the tool, but there are dimensions that you have to observe to get the tool in. Cleanliness is an aspect, so you're making metal-to-metal joints. There must not be a contamination or oxidation, grease or other particles in the process, so you have to be careful of that. That is mainly due to the handling. You need to handle the products before it's going to wire bonding cleanly, but there are processes available to clean them before. And of course it has the smart features, so there's no tooling required. It's a very simple to use setup. Okay, the other part then, of course, is the industrialization. This shows a manual loader, but you can replace the manual loader with an online solution. So this gives you a very possibility to have a flexibility and product design. There's a large gantry, so you can have large or small batteries as well. The process speed is 1 or 2 bonds per second, depending on the materials. The equipment compared to other equipment is less complicated, so the flexibility and the setup, it can be a very interesting calculation to make on the return of investment. An important aspect of the equipment solution is the metrology. As I explained, the bond head, it comes from the industry of wire bonding, and so there's a lot of metrology involved in the movement of the bond head during the bond, and this is creating data, and this data is captured at 100% in real time without any slowdown of the process. So you have the frequency, the amplitude, the ultrasonic resistance, the friction. These are all measured and displayed on the chart, and you have a quality factor as well. So for every single bond is made, you'll have a quality factor. You'll be able to generate that in real time and also draw on that in traceability. There are lots of tools on the equipment itself to reduce operator error. So this is a camera which helps you to calibrate the tool. There's automatic force control, automatic position, and there's also a way of automatically controlling the tool. The tool is a consumable and will change the quality of your process. You need to be able to control that and trace that, make sure the right tool is the right process and the right tool has been changed at the right time. So this is a data matrix, and it will cross-reference to your MES and to your process. It's a Windows process, so there's a lot of software involved. Here are some examples. So you have offline programming, you have a network which allows you from one program to another between the wire bonds. There are a number of tools as well. The quality control tool is generating your quality control factor, and all this data is then exportable in data format. And then this is explaining the way that the system can be built into your MES, into your factory. So there's a dashboard which will then coordinate the data between wire bonding and survey their use in real-time production. There's interfaces available to interface to your house MES solutions, and then there's a custom network which is also available called the PBS. Okay, so that's the last slide. Thank you for your attention. My name is Ian Blanchard. Say again, if you have any questions, please come and see me. I'm downstairs. We have, for your information, a wire bonder on demonstration in Évreux, in France, from April 2023. We'll be welcome you to join us sometime. Thank you very much. If there are any questions, please go ahead.